Hi, welcome back. In this video, I'm going to work a few of the homework questions with you. That's the ones that typically students get stuck on. Questions 1 through 3 is just practicing your derivatives and writing. I would highly encourage you to do those. You can definitely show your work on your piece of paper there. But I want to take a look at question number 4. Question number 4 is always a very challenging questions for students. And it says, suppose that we have a function f and it's approximated near 0. So they're telling us, of course, that this is Maclaurin right there. And it's a third degree Taylor polynomial. So we're telling us that it's n equals 3. So it's a third degree Taylor. And then they give us the polynomial itself. It's -3 plus 7x squared minus 7x cubed. And they're asking us to find the value of the following derivatives. And to do this, we have to look back at our Taylor. Everything involved for Taylor involves this little polynomial right here. It is the nth degree Taylor at their center over n factorial x minus c to the n. Now, I write that down a lot because all of Taylor polynomials and even Maclaurin use this same formula right here. This is the largest, most important formula that we have for like almost 30% of your AP exam right here. So you want to know this, okay? All right, so the first thing they asked me to do, they want me to find the value at 0. So the right up here, the value of the function at 0. So we know from our Taylor that this is f superscript 0. So they're letting us know that n has to be 0 here. And I can do this by looking at the coefficient. So to find the value of the zeroth derivative, we're really looking at the coefficient part of it. This whole part right here is the coefficient. So I am just going to use my coefficient part and plug it in. So this is saying f0 over 0 factorial x minus 0 to the 0. Whoops, sorry, I don't want that part right there. I don't really need this part right here because I'm really, again, only interested in the coefficient. And that we know has to be equal to -3 because remember, this is n equals 3. We look at the degree, will tell us the derivative, which derivative we're looking at. Right here, for example, this is n equals 2. That's my second derivative. And the -3 doesn't have any x on, so it's like the original function. So I know that this has to be -3. So to get the value of that function at 0, this is going to be -3 times 0 factorial. But we should remember that 0 factorial is just defined to be as 1. So we get -3. So what if we want to find the first derivative at 0? Well, we're saying here that, oops, sorry, n equals 1. And I do the same thing. Fn of 0 over 1 factorial. But if you notice, there isn't any degree 1. So what's the only way that can happen is if that value is 0. So we're going to set that equal to 0, and I can solve it. The value of the first derivative is 0 times 1 factorial, which is just 0. Let n be 2. Let's find the value of the second derivative. Same operation. I'm going to set it up. The value of the second derivative at 0 over 2 factorial. Well, what's that going to equal? Well, my second derivative is right here. I'm only interested in the coefficient, and it's a +7. So this equals 7. Therefore, to get the value of the second derivative, we're going to get 7 times 2 factorial. Well, 2 factorial is just 2, so that's 7 times 2, which is 14. Ready? Let's go and do the third derivative. Now let n be 3. Same thing. 3 at 0, the value of the third derivative at 0 over 3 factorial. Because remember, the notation is this. This is the value of the nth derivative. That's the value of the nth derivative over 3 factorial. And this is going to equal, well, what is it going to equal? Well, the value of my third derivative up here is -2. I know that because my degree there is 3. So that's telling me that's the coefficient for that. Coefficient for that third derivative. So this becomes -2. The spot for the third derivative. Sorry, I should say it better. So the value of the third derivative at 0 is going to be -2 times 3 factorial, but we should know that that 3 factorial is just 6. So negative 2 times 6, and we get negative 12. So we got the value. There's the value of the original function. There's the value of the first derivative. There's the value of the second derivative. And there's the value of the third derivative. Don't be a jerk. There we go. So now the next question says, well, do we have a local maximum, local minimum, and neither at x equals 0? So this would typically require a sign chart, but we don't really have enough information about f. So I am going to actually use my second derivative test here. So for the second derivative test, we need to show that the first derivative is 0. So if we look at the first derivative, 0, what do we get? 0. So I can actually start it. So I can now say, since the value of the first derivative is 0 and my second derivative, well, my second derivative at 0 is 14. Now that's greater than 0. Well, the second derivative, you might recall, talks about concavity. So that's telling me that this is concave up. So if it's concave up, this has my critical number down here. My critical number has to be a minimum value. So since the first derivative is 0 and the second derivative is positive, we can say f of 0 is in this case, they would say local, but I always prefer relative, but when in Rome, right, is a local minimum. And that's all you need to write. All right, so I hope you enjoyed the video here. That's a really good question. Question number 4 is always a really tricky one for students, okay? So make sure you can answer that one, okay? Especially on test quiz and AP, because that one they love to say because you really understand Taylor if you can answer that question. All right, anything more here that looks so kind of fun? Good luck with that one. Um, for number seven, we're going to talk a lot about that one a little bit later on too. All right, I hope you guys enjoyed the video. I'll see you soon. Bye-bye.